So now that we're on record, we'll see who comes and I'll go over the lab in just a little bit. The first part, hey, thank you. I wanted to do is I was going to do the iWorks, but I had asked Dr. Uh, Hannah to come in, and the problem is this. Why they're having some significant difficulty with this smart card, what we call the smart card. It's obviously is not very smart because I can't get it to wake up and accept my laptop. So because of that, we're just not going to do the iWorks lab today. I'll set it up for next week because we'll probably go back and do the elect. I can probably do the iWorks and maybe even do that with a neurological type lab in the environmental science lab because it's a much easier setup there. It works fairly easy. So I did want to show it to you what's going on with this particular section. This is one I did. I don't even recall exactly when we did this. So I couldn't, for whatever reason, the software, which is supposed to be on university computers, apparently is not on this or other lab computers. It's not up in the anatomy and physiology lab either. So this was the grip lab, and we'll do it formally just to see if there's any variation. But effectively, what transpired is you have whoever the subject is. You can see the peak. So I just did a screenshot. So you can see here's the electrical activity, the electromyographic activity. Here is the force of contraction. So effectively, I have sensors on the individual's forearm, and they're squeezing a rubber ball. We have designed for this particular laboratory, and you can see when they're squeezing it, the electrical activity, then it drops, and you can see some residual signal, and then again when they're actually squeezing and the force happens. So that is you do that a series of about 10 of those at and I mean, you can increase the pressure or decrease the pressure. Generally, you start smaller and then work your way up until your maximum, maybe somewhere between 5 and 10 grips. And you're just using your fingertips, not the fist. So you can test it for men v women if you wish, or different sized individuals if you wish, however. So we will end up doing that next time because I thought we could combine the two today, but it's just because I can't get the tech and I don't feel like cleaning up this room and then going to that room at that point in time. It just doesn't make any sense to me. Now, the other screenshot is the fatigue. And I mean, you can't see, you're only getting a microcosm. So if you look, this is roughly so you squeeze it maximally and you try to hold it for a minute. And we look for variation. So I've compressed it here on the strip. So here's 27 to about whatever that is, a minute. So it's 59. That's probably 109, something like that. So I mean, so let's say that's 40 seconds. And you notice how the fatigue is setting in, and how even though there's occasional little blips, the general trend, if you sort of did your best fit, line that would fit in there, kind of demonstrates. But here you're still trying to maintain the muscle activity, but there's this element of strength that's depleting. So those are the two things that you do. So we'll try to get two individuals to participate in this, and then I'll see about maybe try to do the EEG lab along with it because we'll be into nervous system by next Monday, quite a bit. So that's the little introductory nugget for that, which brings us to today's lab. Now, at each of these stations, it's a kit that comes from Carolina. I mean, you can use it at different levels. We have some fun with it, just to see what it is. It's kind of a unique system. So, and I made copies. The handouts are there. So if you want to keep it. I can print more anytime that are there. And it gives you the mechanism, the overview, and the mechanism of muscle contracture, the calcium and the troponin and the tropomyosin. And we get serious when it starts on the glycerinated muscle system. That's what we're using now, and these appear to have been used. There's just a little bit of muscle left. From my looking at these, and we put them in the freezer. This is in 50% glycerol. These are rabbit muscle. This is rabbit, most time they're using a fairly long strip of psoas major muscle which is sort of like from the hip in the interior, goes through the obturator frame and inserts on us into the lesser trochanter. Nice of you to join us. Thank you. Happy to see you.
Happy to see you always.
So I already have children. Too many. Driving me crazy. The next thing is, where is my daughter's going to take us out of this country when and if she ever gets back?
Aren't you going to Cancun?
I could maybe, she hasn't, we could be anywhere.
Where do you want to go?
Israel.
You want to go to Israel?
Yeah. Eretz Yisrael, the Holy Land. We do a
Okay.
joint tour of Christian and Jewish, places.
Out of all places, I thought you were like Jamaica or.
No. I've already done the island. I'm talking about, I can walk around, I want to walk around all those things. I want to float in the Red Sea.
Oh, okay,
Or
okay.
dead in the float sea. Whole Sodom and
I
Gomorrah
did not see
thing.
that coming. That was a good answer.
Oh, hey, we know where we want to go. I says we don't happen to have like the 20 grand or so we're going to have to do this. Just floating around, floating like dead seas. Floating, but that's where we like. Considering that, although she's considerably younger than I am, I'd like to get this done before I go back to real me. Not that funny.
Oh, sorry. I won't laugh. My bad.
So, and again, just to reiterate, so this is little bits of teased rabbit muscle that has been glycerinated. So if you read along, it's different from living tissue. It removes ions and it removes ATP and disrupts the troponin tropomyosin complex. So the binding sites on the actin fibers are no longer blocked. You don't need calcium. However, in the absence of ATP, the myosin heads are not activated. So each of you have little packets, and if you run out, if one's low, just share it. And you'll see that the packets have little vials that contain, one is just distilled water with some ATP, one is distilled water with ATP plus electrolytes, and one is just the electrolytes and distilled water. We can use them we should use both, look at them both by way of the dissecting microscope, and you should be also getting slides and cover slips to look at them by the standard compound microscope. So we've got both of those. You want to take this is a classic less is more. Okay? And you'll probably, I think you don't want, it's one of those you don't want too much glycerol on it, but if it dries out completely, it doesn't work. So you want to, with paper towels, you can absorb a fair amount of the glycerol. What you do, and the reason you have the petri dishes that are empty, is we pour off the glycerol. Okay, then you remove the very small amount. You don't need a whole lot of the muscle, and then you're going to put the glycerol back in the tube, as well as the little stick that has all the remaining muscle. Whatever muscle you test, that you can just discard. You can discard that. It's not "quote unquote" hazardous waste. Okay, so after the muscle is contracted, it won't relax it because there's nothing else to put it back. And so what you have is the vials, and we've gotten a couple of kits over the years. So there are little white things you have, and are just in the styrofoam. And all the other stuff you need is up here. We always put them back in the freezer, and the solutions we put in the fridge. So just to go over them with you, you're going to remove the strips which are tied to the stick from their test tubes. These contain hundreds of fibers. There's a lot. And you don't need a lot to do this. And most of the students who have seen the motion see it better with just where they can barely see it. If you get a big chunk, you're not going to see the motion. Okay, that's there. Pour the glycerol from each test tube into the petri dish. Save it. Cut the strips and scissors here. If you want to have a blade, I'm sure you can find it. Into pieces about 2 centimeters, about an inch. Drop these into the petri dishes. One piece of muscle is sufficient for each individual or team, although individual work is preferred with your team. Each student will distribute some of the glycerol and one little section of the muscle tissue into the petri dish, and then we'll put it back in here. And you know, you can just put the stick back in here, and then we'll pour the glycerol in at the very end. We just don't want to make sure it doesn't dry out. You can see all the stuff that you need. We have ample supply of glassware and other things that are there. So the amount of glycerol on the slide, the concentration of the ATP, the ions, and the width, particularly of the strand. So you have some of those ones you use in the micro lab, those clear rulers. That's what you can use, and you should be able to, roughly within 10 seconds, if they're going to contract at all, you should be able to see the contraction. Okay? If everyone works for you, I mean, I think you should at least take a look at it. I think it's fairly easy under the dissecting microscope, but you can use the light microscope just as well. You should have a cover slip, I think, high, dry. I mean, I think you could have the cover slip on, you can only use high dry, because you can see it looks at both low dry and high dry. So the procedure for students, stage dissecting microscope, and thinnest strand will usually have 2 to 4 fibers. Anything larger, so I mean, if you're getting a strand that's really as large as, let's say, the tip of a pencil, that's probably too large. Okay, so you want to mount the strand on a slide with a cover slip, plenty here. And every time you use a clean slide. And once you do test one set of muscle with the reagents, you can't add more to it. It's just like that piece is done. We want to test it separately with each one of those. So at that point, transfer 3 or more of the thinnest strands to a tiny amount of glycerol on a second slide. So you use one slide to sort of get it, you can see it grossly. Then you can try to separate the strands. You can use, one of these little, the probes that we have that act like pins. There's certainly plenty of pins here that you could use just as well. Okay, and as you can see, you have a second slide you don't necessarily have to cover. The amount of glycerol needed depends on the amount of light, and it's obviously not very, very warm in this room. So really, whatever glycerol is on there is usually enough. If it's floating, I don't think it's good at all. Measure the lengths, record the lengths, blood the strand, and what they do at first with just the ATP and the electrolytes. Observe the reaction. So you want to get rid of, when you've done that, okay, and then as it says, so you don't want to have any cross-contamination. After 30 seconds or more, remeasure, calculate the percentage of contraction, look at the width as well, okay? You can then take one of those strands and do a quick check if you wish underneath the light microscope, okay, and see if there's any comparison. And then you do the ATP alone, and then do it again with the salt alone. So 3 separate sets of procedures, okay? And that's where it is. So the questions that they pose, that they frequently ask, why do they act permanently stranded? Because there's nothing to oppose it, to stretch it back out again. It's not needed because we've disrupted that calcium troponin tropomyosin complex. Obviously, you have to have ATP as part of it, but the electrolytes play an important role as well. Okay, and so you wanted to see an idea of, is there interference with the potassium and the magnesium? And why are they not contracting? Probably too thick. So again, thickness is your guide with regards to these things. What I would ask you to do is just each group, submit it as a group with all your names on it. So one paper suits all. You could do this in one page with a mini table, easily enough. With the ATP and the salt, just the ATP, just the salt, what you see, and then analyze the results, some kind of conclusion. Happy days. Sound like a plan? I love that. And let us begin. So you have all this stuff here. We'll get more if you need it. There's certainly more slides, cover slips, instruments, etc., etc. Anytime you want to start, knock yourself out.
What's the maximum you can?
Oh, I'd say 4 or 5 would be fine. You can move around. I'm seeing if I can find any of these images. Okay. Here. I mean, you might. This is obviously the thing, everybody. So you can take a look at. I mean, these are just some kind of the images that you might see at some juncture.
I checked my phone and I just saw like the one you messaged you, the one you called to. Like, bro.
Yeah, was it that one? The one all the way back?